We will solve applications involving exponential equations in this problem. If you haven't already, pause the video to read the example. You'll see that you're given the model in terms of t, the year t, and you're also told that P is the population in millions of people. So I'm going to go through this process of solving for at least part A, where we're asked, according to the model, when will the population of the country reach the following: 308 million people. So the first thing you notice I've done here is where we have P of t, I've now substituted the known value, 308. It was already in millions, so I just write 308. And now I'm going to start that process of solving this equation. So I'll start by dividing both sides by 280. And that gives me 1.1 equals 1.009 raised to the t minus 1997. Now, I did that because I wanted to isolate the exponential piece of this problem. So I just divided by that coefficient, 280, on both sides. Now, after this, what I want to do is change this exponential equation into a logarithmic equation. And I'm going to choose using base 1.009. So I'm going to do log base 1.009 of 1.1 equals the exponent t minus 1997. Now, as long as you have an updated calculator or even Desmos, you can type this in and get a value. If you have an older calculator, you may need to use the change of base formula. That's a possibility. But when I do that, see, I'm using my updated calculator, I get that the log expression is approximately 10.6376. And then the last thing to do would be to add 1997 to both sides, and I get 2007.6376 equals t. So about rounded to the nearest year, that would be 2008. But I didn't copy the full problem here on my screen, but it says, during what year is the population 308 million people? So it happens during the year 2007, a little over halfway through that year. So that's the value that we'll use as our answer for that question.